Number 19, Fall 2011 final exam. We're almost there. Two more problems. This one, we're given information about a solid sphere moving along a track. It goes up a hill and speed at the top of the hill. We want to determine the height of the hill. Alright, so quick sketch here. Here we are at the bottom. At the top. So we'll use an obvious datum at the bottom of the hill for gravitational potential energy. We're given the speed 3.5. Okay, and we are assuming it's rolling. And let's see, speed up here is 1.5. Okay, so conservation of energy. We're going to have some initial kinetic energy. So let me write that. Ke translational plus Ke rotational is equal some final kinetic energy. Ke translational plus Ke rotational plus some gravitational potential energy. Alright, call that state 1, that's state 2. We'll have 1/2 m. What happened there? One half mv squared plus 1/2 v1 plus 1/2 I omega 1 squared is equal to 1/2 mv2 squared plus 1/2 I omega 2 squared plus mgh2. Okay, we know every term in this equation, or can calculate every term in this equation except for my h2. Let's see. Solid sphere. I for a sphere, again looking it up, is going to be given on the cover page. Solid sphere is right here, 2/5 mr squared. We'll go ahead and get that number. Mass 0.6 and radius 0.05. Okay, we're going to work everything in units of kilograms, meters, and seconds. Okay, so all these terms will be energy, Newton, meters. Works out that way. Alright, that number comes out to be 2 divided by 5 times 0.6 times 0.05 squared. Pretty small number. 6 times 10 to the minus 4th. Okay. We can go ahead and calculate our omega. This is our V1. This is our V2. We can go ahead and calculate omega as V over R. So omega 1 is 3.5 divided by 0.05, 70 radians per second. make it 2 is equal to 1.5 divided by 0.05, or 30 radians per second. Okay, so now I think we have all the numbers to plug in here and solve for H2. So I'll write it out once here. 1/2 0.6 3.5 squared plus 1/2 0.0006 times 70 squared is equal to 1/2 0.6 1.5 squared plus 1/2 0.0006 30 squared plus m.6 9.81 H2. Alright, let's see if we can get everything to work out here. Let's see. So I'm going to calculate this, subtract off that, and then divide through by that. 0.5 times 0.6 times 3.5 squared plus 5 times 6 times 70 squared. Okay, 5.145 minus 0.5 times 0.6 times 1.5 squared minus 0.5 times 1236 times 30 squared. So that net energy is 4.2 divided by 0.6 divided by 9.81. 0.7135 or 0.714. That will be meters. Everything's consistent. Okay. If we were to work this out sort of in symbolic terms, I believe the mass would cancel out, radius would cancel out, and we didn't even need to know those values. But most of you will work it this way, and that's fine.